Right, this one was on data test practice 3, I think, voltage versus current. I just want to go over it again on video so that you can watch it. So a mathematical relationship, so we've got, I haven't got it printed out, sorry. We've got our linear trend line, we've got our max, and we've got our min. So we're going to be taking the maximum gradient and taking the minimum gradient from it, and the same with the y-intercepts. The first question actually says identify the systematic error. Systematic error occurs, that stopped. That looks better. Systematic error is caused by calibration errors. It's caused by inbuilt error within the machine. Sometimes when you take a measurement, you change its value simply by the process of taking it. So systematic error can be inbuilt, and it shows up when in a relationship the line should go through 0 and it doesn't. So there's a significant systematic error, and it's shown in that y-intercept, which is the c in a y equals mx plus c. So when it says identify the systematic error, you can say it's this, it's the y-intercept. Righto, so we're going to do the mathematical relationship from those, and you've got this printed out, so you'll be able to do that. So first step is to find the gradient uncertainty, so plus or minus max minus min over 2, and that's plus or minus. Might be a good idea to even just go down and give yourself a little line of plus or minuses, because it is easy to forget them and they are important. Get the full marks, you're going to have those in it. So plus or minus, the maximum is 370.55 minus 332.54 divided by 2, and that gives us 19. Then we're going to do the same thing for the y-intercept, plus or minus. I'm going to do that from now often because sometimes I forget them as well. Rightio, plus or minus, it's absolute max y minus min y over 2. This one's got a negative in it. You have to put the negative in. So it is 0.0097 minus 0.2938. And that's over 2, and that comes to, now it's absolute value, so the negative's going to disappear, but you needed it in that part to get the difference in size between the two. 1518. Righto, so we go back then, and I'm going to go back here to our linear trend line. So I've used those gradients and I've used those y-intercepts. Now I'm back here to this linear trend line. So y equals 357.72, and it is plus or minus the uncertainty we just worked out, 19 x and plus 0.2468 plus or minus the uncertainty we just worked out, 0.1518. Then we go back to our graph and we go, well, what does y represent and what does x represent? So y represents voltage and x represents current. So we've got voltage equals 357.72 plus or minus 19. X equals current, which is a capital I. And that's the mathematical relationship. Don't get confused about this and put an A in there. Amps is what current is measured in. So that's the unit that it's measured in. It's like if it was time and then that was seconds. Right, so that's only, it's not what you use in a formula to represent current. That's what it's just measured in. Right, so this is our mathematical relationship here. So again, if I was marking this, I've got 1, 2, 3 cinchy marks. Righto. The last bit, draw a conclusion that quantifies the magnitude of the resistor. So I've got a graph that has V and I, and it wants to know the size of the resistor, the magnitude of the resistor. Do I know an equation that relates V, I, and R? Yes, I do. V equals I, R. V equals IR. I'll go back and I look at my graph and I go, what would the slope represent? Rise over run. So voltage over current. So I rearrange this formula so that it matches that. So I've got slope equals voltage over current. And this formula, V over I, that equals R. So I'm just getting that now. And it goes straight down there. So the resistance equals, it's the slope. We just worked it out. 357.72 plus or minus 19. And resistance is measured in fat legs or ohms. Now, if we want that as a percentage, we need this as a percentage of that. So that would be the percentage uncertainty. So we would have 19 on 357.72 times 100%. 19 divided by 357.72, which is 5.3%. That's not bad in an experiment. So the resistance is 357.72 plus or minus 5.3% ohms. Calculate the percentage error if the resistor was marked at 400. So it wants to know the resistor was marked as 400. This is the value that the experiment established. So that's called the percentage error. So for that, we need the absolute value of, and it doesn't matter if you go accepted minus experimental or the other way around. Don't bother trying. It's just the difference between the two. So accepted, which is the printed value on the resistor, minus our experimental. Some books call it, and I think yours does call it, observed, over the accepted, times 100%. So we would have 400 minus 357.72 over 400 times 100%. It's going to be about 12, I think. So we got 400 minus 357. Oh, 10.6. 10.6%. Forget that that's the absolute value. Righto, so 10.6% would be the error.